So welcome everyone to this talk that we have called From Legacy Chaos to the Promised Land of Domain-Driven Design. And I would like to say that it's so nice to be at a DDD conference with people like you that I like to think share our passion for domain-driven design. It's great. I'm Ellen. I'm a software developer. I work at Headshed, a startup company in Norway, creating sales software. And I used to work at Statoil with Anita and other great people.
Yeah, and I'm Anita. I have been working with software design for more than 20 years. I am working at Statoil. I have a technical education and I love to code, but my passion has mainly been usability or UX. And I read the famous DDD book in 2004 and really fell in love with it when I jumped back into coding again some years ago.
So you probably did not come here to hear about us, but hopefully you would like to hear our story. And it goes like this. For about 2 or 3 years now, we have been working on gradually modernizing a large and complex business-critical application in Statoil. The application is about 20 years old and a real giant. We wanted to rewrite this giant piece by piece by using ideas from domain-driven design and also behavior-driven development. It has been a lot of blood, sweat, and tears, but also a lot of fun. So we would like to share with you now the experiences that we have had so far along the way, both the sunny parts and the rainy parts.
Yes, and to provide a bit more of a background of our story, I would tell you, wrong direction? I would tell you a bit about Statoil. Statoil is a multinational energy solution company. It has more than 20,000 employees and it has its headquarters in Norway. It is the world's largest offshore operator, and it has a special role because it's responsible for handling the Norwegian government gas market shares. And it is the second largest gas exporter to Europe. In the more recent years, Statoil has taken the first step into working with new energy solutions, and it's the major owner of the world's first floating wind farm. I need to learn this clicker. Okay, but the solution we are talking about is called Energy Boss. It's a back office solution. It has its core related to gas handling, and it is focusing on handling gas contracts, selling gas to consumers. In a really high level, we can divide it into two. One is invoicing focused. It classifies the gas into different set of quantities based on a set of secret rules, and based on this and the price, it makes the invoice. It sounds as easy that it's boring, but I will show you the rules in the core of the gas sales agreement. It's not very boring at all. And the other part of the solution is more related to financial services. Here, it makes the detailed transaction to be sent to Statoil's central accounting solution. And one thing is that the amount calculation have to be correct, but just as important is the rules related to the quantities. It must be possible to trace that no gas has disappeared. Another of the main things that financial services does is that it split all the incomes and all the costs correctly between Statoil and Norwegian government, since, as I mentioned, Statoil has this special role of handling the government's gas market share. This makes kind of buying an off-the-shelf financial solution out of the question. And Energy Boss is an in-house made solution where the first line of code was written in 1993. And you heard correct, 1993. Think about that. Some of these lines of code are still running today, making valuable functionality for the users. My teenage daughter back home wasn't even born in 1993. And the solution has been constantly growing since the start. Around year 2000, it was a complete rewrite of the client side of the solution. A terminal-based interface was thrown away, and we made new graphical interface in Visual Basic. Since then, some of the screen has been enhanced in C#, but the majority of screens are still in Visual Basic. And the strategy, by the way, for this renewal was, the calculation on the server side is working, don't touch it. Don't touch it, just be on the client. So the server side has been growing since the very start. So what started out as a cute little angel guarding and helping our user has been constantly growing and becoming really huge. But at the same time, it has actually managed to keep up with the changing need in the business, meaning that it's still a very important solution for our users. And I think that's important. When our stories start, yeah, there's a lot of technical legacy, but the functionality was quite up to date. And we have managed to do this by constantly adding this functionality, and that comes, of course, with the cost of having a huge code base. And this server side was written in a fourth-generation language called Gen. And that language is really tangled together with the database. It actually forced the ones that code to select valid code lines for a menu. So restructuring and moving code around, that is kind of out of the question. So refactoring has not been a way of working for us until C# came along, which is the language we use on the server side today when doing new stuff. And since this was so closely related to the database, and back then, we were very busy with doing reusable code. And our team was excellent in doing this. So we had some part code that is kind of used everywhere in the solution, meaning that if we change it, we have to regenerate it and retest it. And I didn't mention, but there were no automatically test support at all. Not one automatically test, meaning that the test demand was pretty enormous. But on the good side, when our story started, we had already decided to use DDD, so we did not need to take that fight. And we had a team that have been working in the area for years, knowing the business well and cooperating in a good manner. And that was really needed, because there was a lot of icelines out there with code only known by 1 or 2 persons, and they were typical the only ones that could be able to change it. Oh, and we did much more upfront design. So, and we had these handovers, and handovers does not always work well. But being good in upfront design, having this team that works so good, we managed to deliver about 2 main deliveries every year. And for each delivery, we had 2 weeks. 2 weeks of testing. And that was by the team. And then we brought over the business people. And they sat for new 2 weeks of testing. And for me, this was the most boring part of the year. It was just testing, testing, testing. But you have to do what you have to do. And doing all this testing gave us the opportunity to have control even in the legacy solution. So wait a minute, why do we talk about this land of legacy chaos? When our story started, the user was quite happy with the functionality and the support, and the team managed to deliver. That's true. But on the other hand, when this island of code, only known by 1 or 2 people, and no automatically test support, meet the demand of having a cross-functional team where everybody should be able to code, and these 2 deliveries a year meet the demand of delivering code to production often, well, then the feeling of chaos appears. So we were lucky in a way, because I think this feeling of chaos, when you feel that, you understand that, okay, what have been working in the past will not necessarily work in the future. We have to do a change. And then due to a technical risk assessment, a project was launched, a transition project where the service side of the financial services part of this giant was going to be rewrite to C# and at the same time do a more modular solution. And the good thing with project is that project is funding and it's opportunities. And having this let us to have an opportunity, but how to get there with a team knowing the business well, but not having so much experience in DDD and BDD? Well, let me talk more about that.
Yeah, so I came into this team about 2.5 years ago as a lead developer. And in the beginning, I thought that my main role was to lay out the new architecture for the others to follow. So that's what I did. I just told everyone how I wanted the new code to look like. And they said, okay, and went to do the work. But when I looked at this code afterwards, the architecture and the design decisions that had been made, it wasn't exactly what I thought I had explained. So I soon discovered that changing software architecture and code isn't really about changing software architecture and code. It is about the people. It's about each individual and the interaction between them. It's about helping team members changing habits, to mentor and teach new skills. But most of all, to walk the line together. Doing this together as a team, not this one person running in front and hoping that the others will follow. Changing or helping people to change habits is much harder than changing code, but also a lot more interesting. So I learned a lot about people, about my team members during this project. I learned how very different they are when it comes to personalities and learning styles. For instance, one person in this team liked to be told in quite detail what to do. And she enjoyed having a more experienced programmer sitting next to her, especially when doing new stuff. Another person in the team would rather try out the new things by herself. And if I did the same to her, like sitting next to her, that would just make her uncomfortable and it would hinder her learning. What she did like, though, was to have someone to look at the code afterwards, giving her tips on what she could have done differently and why. But again, when I did the same thing to another team member, giving him tips afterwards, he got mad and felt that I was just criticizing all the work that he had done. What he preferred was to have more upfront collaboration and design discussions, and that he was being trusted to write the code in a good way. So I had to learn all these things about my team members to be able to work with them in a good way. And I did some mistakes along the way. I know that I hurt other people's feelings, and my feelings got hurt. But eventually we learned these things about each other. We learned how to work together even better. And for me, this relational learning and change was really the most inspiring about this project, seeing this happen. So there were a lot of things that we had to learn. And for this team, maybe one of the greatest challenges was to change from thinking about the data and to think more about the feature of the system. A task that I often like to compare with that of changing from a geocentric view of the universe to a heliocentric view of the universe. Now, nobody questions that it is the Earth that revolves around the sun. But when Copernicus introduced this idea in the 16th century, it took the population 100 years to accept the fact that the Earth is not the center of the universe. The mind shift change in this team did not take that long. But it might have been equally hard and painful, because they were used to this universe where the data was the center, The database was the truth and the starting point of everything. And now I wanted them to think more about the features, the behavior of the system, letting the data be more of a side product of that. And that's not an easy shift to do. So to help me and the team in this process, I would like to thank Julie Lerman. Her insight and articles about domain-driven design for the data-driven mind has been really helpful, both for giving us tips on how to do this transformation, but also for me to understand which parts of domain-driven design are really hard when you're not used to think that way. I strongly believe that when you are to learn new things, it's good to do it in many different ways. To read it and write it and try to involve all your senses in the learning process. So one of the things that we did was using roleplay. We actually had the whole team play out a gas sales algorithm in 2 versions. First as a transaction script, and then using ideas from domain-driven design, just to really feel the difference between these 2 coding styles. So each of the team members were playing a class, and they all had different responsibilities and different knowledges, and they had to collaborate to fulfill the task of the algorithm. And this collaboration looked very different in those 2 scenarios. This was mostly for fun, of course. Probably a bit embarrassing for some, but still a bit of learning. You know, when you have strong emotions like joy or embarrassment, that's when you remember. You don't forget your most embarrassing moment. And also, I think this experience is sometimes has helped the team when they discuss the design or trying to find the design of the code. They sometimes still use this experience. We did other normal things too to increase the DDD competence of the team. And one of the things that kind of surprised me was that the people who grasped these ideas the first were not the most experienced programmers of the team, but rather the more soft-skilled people, which tells me again that domain-driven design isn't really a technical programming skill. It's a mindset. But it's a mindset that will form your code, even the technical parts, in a certain way.
Yeah, and I can tell you a bit about my journey after Ellen came into the team. I think with my background in the usability area, it was so easy for me to fall in love with DDD and really believe in its power. In the usability area, we had this model stating that if you communicate the functionality in the user interface through a model similar to user's mental model, you're more likely to get a usable solution. So for me, UX was DDD was kind of just UX for us that actually implements the solution. And to learn doing DDD with C#, we had these study groups because we were more people starting on this journey together. And we had pair programming with mentoring by Ellen. And for me, having these boundaries, these beautiful boundaries of a bounded context with automatically test support was a safety net. And it was a brilliant way to start to learning DDD. And I think for new team members coming into the team, knowing the technical things but not knowing the business, having these boundaries and the bounded context made them be able to produce and to contribute much faster too. And in order to let everybody in the team learn more about the business, we had workshops and other meetings with our users. And the purpose here was to knowing the business, but also to knowing their view of the legacy solution. We needed to know what part was working brilliant, what part do you need enhancement in, and is there any functionality you are not using anymore? And in addition to having this workshop, we actually read a lot of legacy code. And that sounds maybe silly, but our users are able to confirm a rule, but to ask them, could you please list all the rules that you have stated the last 25 years since we started in 1993? That's a quite impossible task to do. So for us, this combination of the workshops and the code reading made sense. And typical, the whole team was engaged in deciding the high-level design, meaning we discussed bonnet context. We discussed their namings, their aggregates, what should the responsibilities be, what should the relation to other bonnet contexts be. And we think it's actually a good thing to use some time and to engage the whole team in these kind of discussions. And it is so important that if you miss on first try, you should redo it, or we wanted to redo it, so that was what we did. When it comes to the structure inside a bonnet context, we didn't use much time to do discussions. We used the onion architecture, and that guided the internal structure for us. And we had code reviewing and pair programming to look out for each other, to be sure that no business logic was sneaking out in the repositories and things like that. Yeah. So doing this high-level design was a group activities. And when it comes to the features, the detail rules, we implemented them in feature test. And Ellen will soon explain much more about that. But for me, with my background, working in more than one waterfall project, and having this tool where we had to implement the whole calculation together because we couldn't restructure or enhance, I think it is so good just to take this one feature and forget about 100 other features that is also relevant for just this one calculation. So you take that feature, you make it work, and then you refactor. I'm sure that is a very well-known pattern for you all. But for us, it was a complete other way of thinking. And for me, it was a bit of a lightning moment when I understand that it is okay to do something, to code something, to design something that you know will not be your final design. Because if the next feature come along and it implies some restructuring, then you refactor because you have got better insight. And the result in the end will probably end up with better piece of code by working that way. Oh, did I take too much for you? So over to the feature test.
Yeah, my favorite topic. So you probably got the idea now that really we wanted to use domain-driven design and behavior-driven development. And the combination of these I find to be extremely powerful. One thing is, of course, that behavior-driven development helps you discover the domain and helps you kind of put the business domain into the code. But it also works the other way around. And I'd like to try and explain what I mean with that. And that kind of starts with testing. Because when it comes to testing, there are a lot of challenges. And even with the best intention, I think it's easy to mess it up. I am really fond of automated tests. And I fell in love with test-driven development when I got introduced to that about 15 years ago. I remember that because it was the same time I fell in love with my husband, being in the same TDD course as me. Anyway, I used to think that the more tests you write, the better. But when you do that, you get a lot of code, which also needs to be maintained, just like the production code. And my experience is that instead of helping, this test just gets in my way when I want to refactor and work with the code. They make me feel stuck with the code that I have, and I find that very frustrating. On the other hand, writing none or very few tests would of course make me nervous when putting that code that I have changed into production. And I will not have the courage to not do a lot of manual regression testing, which is not that much fun. So a type of test that I used to write a lot were tiny, tiny unit tests. That's what TDD was all about, right? That you wrote this failing test for a property and then implementing this property on the class to make the test pass. And you can have 100% test coverage this way, testing every unit completely, but separately. That doesn't make me less nervous, though, because how do I know that all these units work together the way they should? The answer could be having huge integration tests testing everything together, which brings me kind of back to the feeling of being stuck, because I find it hard to change anything when everything depends on everything. Oh, and then you have the mocks and the mocking frameworks. And I used to love them very much too when they came a few years into my TDD career, because now I could test everything. If there were some hard parts, I could just mock them out, and I could test this part of the code and this other part over here. It was brilliant. And especially with the mocking frameworks, it was so easy, I thought, until I had to go back and look at the code that I had written just a few weeks earlier. And I got so confused. I really couldn't see what I was testing. I thought that it was testing the production code, but it looked like it was more testing the mocking framework. So now I don't like mocks that much anymore. They make me feel that I don't have control over what I'm testing. So, how to find a good balance for automated tests? I have strong feelings about this, and in my opinion, a lot of projects do not give this enough attention, and they end up doing a little bit of all of this, which in my mind gives quite a messy test regime. It might look kind of like this. So if this is your cute little system with your classes and modules, you might put a test on top here that mocks out parts of the system, and another test over there mocking out another part. Maybe a little unit test in here, another test in the middle here, and so on. We thought about our test architecture, and it looks different. This is what we did, and for us, I think it worked really well. Our test strategy was closely related to our bounded contexts. So if this is one context over here and another one over there, and they communicate with each other through this anti-corruption layer, they also read and store data in the database through the repository, and at the top, we have the service layer that exposes the feature of the context. Our strategy was to put all our tests at the top only. We aimed at having no tests at all in the middle, except for maybe a few unit tests. And the only places we would mock out anything would be at the border of the context, at the anti-corruption layer and the repository. With this strategy, we got feature focus. All our tests were focusing on the actual features delivered by the system, the behavior that our users cared about. And we got almost complete coverage of these features because every line of code within that context that would contribute to this feature were being tested from the same point. No fakes, no mocks. And this actually gave us more confidence than having lots of tests all over the place. And they were not like huge, huge integration tests since we were cutting them off at the border of the context. So we had to write and use some mocks. But it was limited since they were all put at this same place, and all the tests within one context would use the same mock. We would often handwrite them, and we tried to keep them really simple and easy to understand. What I liked the most about this strategy, though, was that it enabled us to do all kinds of crazy refactoring. We had the test at the top, so we knew we didn't break anything. And also, since we didn't have any tests in the middle, all the refactoring was about the production code. There were no tests that we needed to refactor when reorganizing everything. And being able to do this, I think, gives a more maintainable code, even though you add on features. But most of all, the feeling it gives to be able to work with the code this way, to mold it and twist it and change it in every possible way, in a safe way, it's so powerful. It's such a freedom. It makes me extremely happy while coding.
Yeah, I know, Ellen, that you could talk about this the rest of the day, but
yes.
I think we will continue. But if anyone grabs her, you will get a lot of inspiring stories. So, next topic. How did we do this? Splitting our giant. Because we wanted to go to this promised landscape of DDD. Well, that was the easy part. You know, you just carve out the correct parts, and then you take one of them, and you throw it, and that's important. You have to throw it into the correct bonding context. But if you just do that, by magic, everything works. It's domain-driven design. No, it doesn't work that way. I'm sure you all can imagine that it's a hard task to do. It's like if you renovate your house, if you move away, that's one thing, but if you live in it and you demand the same level of comfort during the complete process, that is hard. And our giant, our legacy solution was used by our users every day. It had to be up and running. So we had to figure out, how do we do this without using the older recipe that was always to do everything in one big bang? Well, as we said, our story has sunny part and rainy part, and for us, we think the sunny part is the bonding context, and we put the rainy part in the database, meaning that we used the database as an integrator between the different, the old legacy code and the new part of the solution, and we were not able to have a separate database for each bonding context. Another thing that was helping us a lot, in order to deliver code to production and to do this in a stepwise manner, was to exploit feature toggles. I don't know if you all know what that is, but for me, it's kind of what you see in the railway station. It's the switch. You can make the train go that direction or that direction, and you can switch it back and forth as many times as you want. And we put these toggles or switches in our code. And since this has been so important for us, for our achievement, we just want to share some stories with you. In one story, we were doing this rather huge calculation in context A, and this calculation depended on a split number from context B. And since our team had the responsibility for both those contexts, we were planning to do this at the same time. But then the business, you know, it's always the business. Our business started to discuss just at this point if they should do the calculations in context B much simpler. They want to simplify the rules. And that took actually some months to decide upon. So what should we do? Okay, we put a feature toggle. So we reuse the legacy code and the calculation with the rules as they were at that point. And by doing this, we could finish the calculation in context A and put that into production. When the business had decided the new rules, we could implement those in context B and just use the toggle to switch it or activate it. And I think in this case, it was kind of a way to work because we were so used to use this feature toggle that we did never discuss should we stop doing the calculation in context A. Our solution has quite a few of these more complicated calculations. And what we did when we start with a new calculation, we put a feature toggle in the user interface, or in the client, not in the user interface. The users are not the one toggling. So we put it into the client. And doing this, since we could put things into production, even we have a calculation that is started but not finalized yet, because it just makes the code go to the legacy code and run that at the start. So that has been very useful to do it more stepwise. And in this case, you see we have more than one toggle. So we put one toggle for each type of contracts. And why did we do that? Well, this calculation for the cost contract, it was the same calculation for cost and for sale, but the cost contract just needed a limit set of rules. So we could implement those rules first. We could put it into production, just activating the calculation for the cost contracts. That made it was good for us to take it stepwise, but it was even more good for our users because they didn't need to start to use the new calculation and feel safe for that calculation for all types of contracts at once. So we got a more stepwise implementation. And stepwise implementation, you all know, that means the possible with a loop of feedback and continuous learning. And just this case, it's the calculation of the detailed transactions to send to Statoil central accounting solution. And the users had requested some enhancement from the workshop that I discussed there, where we asked, where should we do something new? So they wanted to have a template that was enhanced. It was already a template there, hiding a lot of this calculation, but they need some new functionality. So we put a feature toggle in the repository, so we could make the calculation with the old template and the rules there first, and then we could enhance our calculation to use the new functionality in the template that the user has requested and put that into production at the latest stage. So to summarize, for us, feature toggle was really important to avoid this big bang strategy, doing everything in one. We could take a stepwise implementation, and we got this continuous learning as we went out towards this promising land of DDD. So that is one thing. Another thing I want to mention, because it was important for us, was actually that we managed to embrace our legacy solution. As I said, it's hard to have this giant up and running while doing the new stuff. But at the same time, I think it's really important to think about that there are good sides of having a legacy solution. And our team managed to do this. One thing is that we had a perfect fallback solution. In combination with the feature toggles, we could just switch back, which we haven't needed, but it was a safety net for us and our users. But much more important is having a legacy solution mean that you have historical data. And historical data, there is this word saying, data is gold. And for us, I think it became quite true. And this isn't any huge, it's not big data at all, but it's more than enough to be useful. So what we did, we made this comparison, automatically comparisons test. So we took the data we had in a database, that was the result of the legacy calculation, and we compared it to the result of the new calculation. And by doing this, we could be more convinced that we have picked up the right requirement and that we have implemented them correctly. And then we took this even one step further, because we said, okay, reading all this legacy code, it's hard. We spot most of the rules, but we need to use a lot of time to be sure we have spotted them all. So we implemented the rules we knew, and those we spotted easy, and then we started running this comparison test. And every time we got a difference, we used that to drive the next requirement. And for us, that was a much safer way, but also a faster way to get the complete requirement set. And then finally, we also managed to help our users, because with this configuration template I mentioned, they were planning to do a lot of manual testing. It was so important for them that when they configured up the new functionality they had requested, the new configuration, it had to be correct. So we said, okay, we can run our comparison test with a new calculation using their new configuration and compare that to what we have from their legacy calculations. And doing that, we managed to help the users a lot. They saved a lot of time, and the testing was able to pick up issues that will not have been easily overlooked if you had done this by manually testing. And finally, maybe the most important part of having, I'm not able to click. Oh, crisis. I can talk. Someone can take up the technical stuff. Well, finally, having this team with knowing the solution, because if you have a legacy solution, you probably have team members knowing the area. And this experience made it so much easier to get the correct bonded context than what it would have been done if it was a greenfield implementation. So there is good part of having a legacy solution, and we managed to see those.
Those are really a lot of great things achieved there, I think. Don't you agree? Yes. But I've been wondering, though, did we reach this promised land that we were hoping for? I'm a bit of a perfectionist, and when doing this transformation, I wished for everything to be perfect, which it was, of course, not always. And maybe one of the greatest things that I've learned personally from this is it doesn't have to be perfect. It's still good. Every little change makes a difference. It doesn't have to be perfect. I keep repeating that, but I think I believe it too. And having said that, there are, of course, hundreds of reasons for things not becoming perfect. And for us, one of them was that old habits are hard to change. We are 1 month into 2018 now. If any of you have made any New Year's resolutions, you know what I'm talking about. So even if we knew the right way of doing things, we would occasionally fall back into the old way of doing things, like putting data in the center, putting too much business logic into the repository. We would notice this, though, and sometimes we would go back and change it. But often we would leave it there in this imperfect state, but we would learn from it and try to do better the next time, and that's good too. Another reason for imperfection that Anita has already mentioned is that we were rewriting this code while still living in it and using it. And also some parts of the code would never be rewritten, so we had to interact with the legacy code. And also, like you heard, the energy boss domain is really complex. So sometimes it was just really hard to find an elegant DDD solution, even for new stuff. This could also be good, though, because it would give us hints on complex functionality. And what we would do was to go and ask the business if they really needed this complex functionality. And very often the answer was no. They didn't use it, or they didn't even know that it was there. So what we could do was remove this feature altogether, or not take it with us from the legacy code, giving a solution that was easier to use and understand for the users, and code that was easier to use and maintain for the developers. So there were a lot of good things, and even the bad things we kind of turned into good things. So maybe we're there?
Yes, everything isn't perfect, of course not, but it's so much better than it was before. I think more people know the code now. You can click, I can talk. I think more people know the code now simply because we have been able to work much more together. And if they don't know the code, if they had not worked on it, we have this feature test that's easier to guide us, and we also have the automatically test support that makes it easier to dare to do changes. And we have seen so many times that doing changes and enhancement in this DDD landscape, oh well, that's a dream if you compare it to the legacy solution with this selecting code from menu options. So we can refactor now, we can experiment with the code, and we can make it work. And finally, we can deliver to production over and over again without using 4 weeks of regression testing. And I really, really love that part.
So we are coming to an end, we are told. So this is what we want you to remember when leaving this room. And it's that it is possible to go from a situation of bad code to a situation of good code. But our experiences is that it starts with the people. When you know your team members really well and know how to work with them in good ways, that's when you can do great changes with your code. And by doing great changes with your code, will you not only increase the quality of the application, but you will also increase the motivation of the team members, which in turn will lead to even better code. And with good code, we believe that you are able to serve your users in a better way. So with that, thank you for listening to our story. I hope you had some tips that you can take with you. Thank you.
Thank you for this inspiring story. Could you tell us in what way, how did you define the features? What was a feature for you?
So the question was how we designed the feature or how we decided what a feature was?
Both.
Right? Both.
Okay. One feature could just be giving this kind of invoice information, what should be sent to Statoil accounting solution should be really the tax code A, for instance. So it was really detail level, but you can start out just during the happy case, knowing that you got one transaction, that was kind of one feature, and then you add on. So in a way, for me, a feature is a rule, something that has to be implemented inside the solution. It's a good question. I haven't been thinking so much about it, so I don't know if it was a bit unclear answer, but it's really each rule. You have to understand how to implement it. And if you start with a feature test, you have kind of documented it in the code, and you can use that to drive the implementation of it.
Use processes. I'm looking for the link between the user processes and the features you choose.
Sorry, could you repeat?
I'm looking for the user processes, the way the business wants a process to run, and the features you decided on.
Yeah, since we had this legacy solution, and we were doing mainly a rewrite of the server side, the process on a high level seen from the user was not that much changed. In the most cases, we still had the same user interface. So for instance, they had a process that I calculate the voucher, and that was there. And then we had the link of all the rules we know that was part of that calculation. So we didn't, even though we had these workshops, we didn't need to understand everything in a new context because we already had it there. So it was more to see, do you feel your process is working with the legacy solution when we ask the users.
Thanks.
One more question?
Yeah.
Hi.
When you have this old code, how would you decide which feature to more? One which maybe solve a business problem, or one which is easy to implement?
So how we decided on which features to implement?
You didn't get the beginning of my story. When you have your old code and you have some pressure to solve a problem which you couldn't solve in the old code, how would you decide from team perspective, do something which is maybe easier and less risky, or try to solve the business problem?
Good question. I think, or do you want to answer?
Yeah, because while we did this project, we had also a new project on the side. So if there was changes, if that were you asking, if the business needed new functionality, that was a new thing coming on the side, and it got usually that was prioritized first, and that wasn't done by our team, but more by the product owner. Was that?
What we very often have is that we somehow also need the old code. So the new things are somehow not separated in the beginning. So should we just go on and do it in the old code, maybe because it's too complex, and try to solve the easier issue, and hopefully later on we can solve the bigger problem?
Yeah, we kind of did that too sometimes. If we didn't have enough time and it was really complex, like you said, we would sometimes put this complex part within the new code also, not having time to make it perfect. But we learned here last year kind of how to do that, to really make it explicit that this was a bad part of our code. We tried to put it encapsulated in a way and call it something, a very bad way of calculating rule A, something like that. So we had this mix.
Thank you for listening.